Welcome, this is the video lecture covering trigonometric ratios. The learning target is for you to understand similar triangles, particularly right triangles. And your two success criteria is for you to be able to construct a trig ratio and for you to be able to identify trig ratios. Okay, no one says trigonometric ratios. By short, they just call it trig, T-R-I-G, and ratios. And remember, a ratio is a comparison of two things. So let's review a core concept here. And it is parts of a triangle. Given this triangle of triangle ABC, you should see this triangle. Each side here is color coded differently to give you a better visualization. So the first question is, what are the parts of a triangle? You should notice there are three sides. We also call those legs of a triangle. The blue one is line AC. Notice I write two letters, AC, because it tells me it goes from A to C, and it is a line. Then you have line BC, which is the green line. Then you have the red line, which is line AB. So you have three sides and three legs. Next, there are three angles on a triangle. You have angle A, angle B, and angle C. Angle C is special because that is denoted by a 90-degree symbol. So they say that angle C is automatically 90 degrees. Vocab. There are three major parts of a triangle depending on where you're looking at. Here it says looking from the point of view of angle A. So what I recommend you do is draw a person right there on angle A. If you are on angle A, what is your adjacent leg? Well, the adjacent leg is the blue one. It's the one that is closest to you. It's this one. It's your adjacent leg. And that adjacent leg is your AC. So you can say that AC is your adjacent leg. Adjacent leg. Adjacent could also mean your close leg and your near. So those are two ways you can think about the word adjacent. Then you have the opposite leg. The opposite leg is to the opposite of it. So this would be opposite. It's on the opposite side. So you would say that the green line of BC is the opposite leg to the angle A. Then lastly, you have the unique AB, which is the hypotenuse. The hypotenuse is referred to your longest side. And that is denoted by being opposite to that 90 degrees. Okay, the hypotenuse here is the red line. Let's do it differently now, and let's look at it from the point of view of angle A. Here you see that we will draw our person here on angle B so we can understand a couple things. The adjacent leg here is going to be BC because it's the closest one. This is the closest or the nearest leg, which is going to be line BC. Then you have your opposite leg, which is this one, which is going to be AC, which is the opposite because it's on the opposite side. Then you have the hypotenuse, which is going to be the longest side. Okay, that's the hypotenuse. Please understand that if you notice, the hypotenuse is the same for both of them. But depending on your point of view, the adjacent and the opposite changes. The adjacent for A is AC, but the adjacent for angle B is BC. Okay, look at the way it's color coded. Let's do a vocab check. Looking at it from the point of view of angle J, so make sure you put the person here on angle J. You have to identify the legs. Make sure you can be able to write it. There are three legs, the adjacent leg, the opposite leg, and your hypotenuse. Let's do that now. JK is going to be your adjacent leg, which is 32, which is this one. This is your adjacent leg. ADJ is for short. The opposite leg here is to its opposite side, so it's right here. OPP, that's opposite. Then the hypotenuse, which is the longest side, is going to be opposite to that 90 degrees right there at 40. That makes sense. It is the longest side because 40 is longer than the rest. Let's do for 2. They say here that 15 is going to be the adjacent leg because that is your closest or the nearest. KL, which is 8, KL, which is 8, is going to be your opposite because it's on the far end. Then your longest side, which is 17, is going to be your hypotenuse. So that is the hypotenuse right there at 17. 17 cannot be the adjacent leg. A lot of people think this is the adjacent leg. It can't be the adjacent leg. The reason why is because it's the longest side. The vocab check should be able to give you a better understanding of how to figure out what the adjacent leg is, the opposite leg is, and what the hypotenuse is. This leads us up to our core concept of what trig ratios are. There's nothing about trig ratios that you can really derive. What you need to be able to do is just memorize the trig ratios. There's no way around this. So there are 3 types. There's 6, but you're only going to learn the 3 main ones. SIN, which is called sin, in the long, its real name, its long name is actually sine. So you could call this sin. This is really sine. Then you have cosine, which is cosine, or you could say cos, C-O-S for short. Or you could say tan, which is short for tangent. That it's its long name. The angle here, this is an angle. And this tells you from that point of view. So again, remember the adjacent leg, the opposite leg changes depending on your angle's point of view or where you're looking from. Here, it is angle A that we're looking for. So we're going to find sine of A, cosine of A, and tan of A. So let's look at sine of A. Sine is by definition your opposite leg, OPP, divided by your hypotenuse, HYP. That is always the case. The leg that is opposite to A here is going to be BC, and the hypotenuse is AB. Okay? You should already be familiar on how to find the opposite, adjacent, and hypotenuse. Okay? The new part that the core concept is trying to get you to understand is the definition and how to plug it in. So sine is by definition the opposite divided by the hypotenuse. Cosine is going to be your adjacent leg, ADJ, and that's going to be divided by the hypotenuse, HYP. So in this case, the adjacent leg, which is in blue, is going to be AC, and the hypotenuse is AB, which is red. Tan of A. Tan of A is defined by your opposite leg, which is OPP, and the opposite leg here is going to be in green, which is BC, and the adjacent leg, which is the blue leg, which is AC. Okay? Again, you need to be able to look at it from that point of view, figure out what is your adjacent, what is your opposite, and what is your hypotenuse. From there, you can plug it in. These are definitions. You need to be able to memorize this. So, let's do an example. Identify the 3 trig ratios. There are 3 trig ratios from the point of view of angle R. So you should draw that person right here. The 3 trig ratios are your sine, cosine, and tan. Before we do that, you should label your adjacent, your opposite, and your hypotenuse. So 3 is our closest one, so this is going to be our adjacent. 4 is on our opposite side, so this is OPP. Do you see how it's on the opposite side? That's opposite side. And then the longest side, which is opposite to that 90 degrees, Okay, this is your hypotenuse. That makes sense because it is the longest value. Now we can plug it in. Sine. We know sine by definition is going to be your opposite leg divided by the hypotenuse. That is the definition of sine. That was, in this case, ST divided by RS. And those values are 4 divided by 5. That is opposite divided by the hypotenuse. In decimal form, it is 0.8. So you can say that sine of R is equal to 4 divided by 5 or 0.8. Cosine. Let's look at cosine of R. Cosine of R is by definition your adjacent leg divided by your hypotenuse. The adjacent leg is RT and the hypotenuse is RS. We labeled it right here, so you shouldn't be confused. RT's value is 3, the hypotenuse is 5, so it should be 3 over 5. Fraction form, it is 0.6. Last one, tan of R. Tan of R is by definition your opposite leg divided by your adjacent leg. The opposite leg here is 4, the adjacent leg here is 3. Plug it in, you get 1.3 repeating. So this is how you find sine of R, cosine of R, and tan of R. Let's look at the practice problem. Here, it's the same thing, but here you're going to look at it from the point of view of angle S. So put our person here. From angle S. Then we should label our adjacent. So our closest one here is our adjacent, which is angle 4, which is line 4. The opposite is 3. And 5, it is the hypotenuse because it is the longest side. Your three major trig ratios are sine, cosine, and tan. But here we're looking sine of S, cosine of S, and tan of S because we're looking at it from the point of view of angle S. So sine of S, by definition, sine is always opposite over hypotenuse. That is the definition. The opposite leg here is 3, and the adjacent leg is 5. So it's 3 divided by 5, and that equals to 0.6. The cosine, by definition, cosine is adjacent over hypotenuse. That is going to be your adjacent leg is 4, your hypotenuse is 5. So it's 4 over 5. In fraction form, that becomes 0.8. Next, you have tan of S. Tan of S, you have as by definition opposite divided by the adjacent. The opposite leg here is 3. The adjacent leg is 4. So it's 3 over 4, which can be simplified to 0.75. Good. So again, it depends on what you're looking at. Make sure you're able to identify your adjacent, your opposite, and your hypotenuse. All right, so here are your practice problems. You should see these questions before. You should already have it labeled from the point of view of J, what is your opposite, what is your adjacent, and what is your hypotenuse. Okay, so from this point of view, from angle A, from J, 32 would be your adjacent, 24 would be your opposite, and 40 would be your hypotenuse. Angle J is up here. The 15 is your adjacent because that is your closest or your nearest. 8 would be your opposite, and then 17 is your longest side, so that is your hypotenuse. Okay, your three trig ratios that they're referring to here for J is going to be your sine of J, cosine of J, and your tan of J. Let's do this. So sine is by definition opposite over hypotenuse. That just becomes 24 over 40, which is simplified to 0.6. Cosine, by definition, is adjacent over hypotenuse. The adjacent is 32, and the hypotenuse is 40. So 32 over 40. That equals to 0.8. Tan, by definition is opposite divided by adjacent. The opposite leg is 24. The adjacent leg is 32. So it's 24 divided by 32. Number 2. What is the sine of J? Sine, by definition, again, is opposite over hypotenuse. That becomes, opposite is 8, hypotenuse is 17. So it's 8 divided by 17. Cosine. Cosine is adjacent over hypotenuse. The adjacent here is your 15. And your hypotenuse here is 17. So it is 15 over 17, getting you 0.9. Lastly, tan of J. Tan of J here is by definition the opposite over adjacent. So the opposite leg here is 8. The adjacent leg is 15. So it becomes 8 over 15, which simplifies to 0.5. So this is as simple as identifying the trig ratios. Before you leave, I would like to show you some error analysis. Here, we're looking at tan of D. So tan of D is looking from this point of view. And we know tan D is going to be its opposite over the adjacent. So we're going to label this. 35 here is your opposite. And 12 is your adjacent. Okay, so tan of D should be opposite, which is 35. And then your adjacent should be 12. That is the error. They used 37. That is incorrect. Lastly, number 12, they did tan of 55. So here's that person. And we know that 11 is our adjacent side because that is our closest one. 18, which is your opposite. And 21.9, which is your largest one, has to be your hypotenuse. Tan, by definition of 55, is always going to be your opposite over your hypotenuse. Sorry, not opposite over hypotenuse, opposite over adjacent. So tan of 55, what is your opposite leg? We saw that it's 18. And your adjacent is 11. So it's 18 over 11. Oh, wow, they looks like it. It's right here. That should be correct, right? Yes, the tan of 55 is correct. But trig ratios only work for what sort of triangle? It only works for right triangles. Is this a right triangle? No, this is not a right triangle. Why? Because there's no red box right here. Okay, the fact that it's not a right triangle, you cannot set up your trig ratios for it. Okay, all right, so there you go.